Ever wonder what's really going on in your brain during a long run? It's not just about pushing your legs. Your brain is undergoing a wild transformation too. As your feet pound the pavement, your brain starts to flood with feel-good chemicals. Your stress melts away, and surprisingly, you may even enter a meditative, almost euphoric state known as the runner's high. But that's not all. Deep inside, your brain is rewiring itself, boosting memory, creativity, and emotional resilience in ways you never imagined. Ready to find out how your brain becomes your biggest cheerleader on the track? Let's dive in. Today we will talk about what happens to your brain during a long run. It's not what you think. So before we start, make sure to hit the like button and subscribe to my channel. The brain's immediate response to running. As soon as you start running, the brain is one of the first organs to react. The initial minutes of a run trigger a rapid cascade of neurochemical responses. The hypothalamus signals the adrenal glands to release adrenaline and cortisol, stress hormones that prepare your body for movement. Blood vessels in the brain dilate, increasing oxygen and glucose delivery. This fuels the brain's energy demands and sharpens alertness. You may initially feel some discomfort or resistance as the brain works to assess whether continued exertion is safe. During these early stages, mental chatter can dominate as your brain processes stress signals. But as the run progresses, a neurological shift begins. The endorphin surge and the runner's high. One of the most well-known phenomena associated with long-distance running is the runner's high. For decades, this was primarily attributed to the brain's release of endorphins, neurochemicals that act as natural painkillers and mood enhancers. These molecules bind to the brain's opioid receptors and dampen the perception of physical discomfort. However, newer research suggests that while endorphins do play a role, they cannot cross the blood-brain barrier easily. This raises questions about whether they are the primary agents responsible for the euphoric sensations many runners report. Endocannabinoids, the real heroes of the runner's high. Recent neuroscience points to endocannabinoids, specifically a molecule called anandamide, as a more plausible explanation for the runner's high. Unlike endorphins, endocannabinoids are lipid-soluble and can easily cross the blood-brain barrier. During prolonged aerobic exercise, the levels of anandamide increase significantly. This compound activates the same brain receptors targeted by THC, the psychoactive ingredient in cannabis. The result is a profound sense of calm, reduced anxiety, and elevated mood, all contributing to a mild euphoria that runners may interpret as spiritual or transcendent. Enhanced neuroplasticity and brain-derived neurotrophic factor, BDNF. Another remarkable effect of long runs on the brain is the increased expression of brain-derived neurotrophic factor, BDNF. This protein supports the growth, maturation, and maintenance of neurons. It plays a critical role in neuroplasticity, the brain's ability to reorganize itself by forming new neural connections. During a long run, BDNF levels spike, particularly in areas like the hippocampus, which is vital for learning and memory. This not only improves cognitive function but may also protect the brain from age-related degeneration. In essence, the brain becomes more adaptable and resilient with regular long-distance running. Structural changes in the brain, gray matter growth. Surprisingly, long-term endurance running can physically alter the structure of the brain. MRI studies conducted on ultramarathon runners have shown increased gray matter volume in several key regions, including the prefrontal cortex, which is involved in decision-making, attention, and impulse control. The cerebellum, essential for coordination and fine motor skills, also shows signs of growth. These structural adaptations may be the brain's way of coping with the demands of long-term aerobic activity, reinforcing the idea that the brain doesn't just passively endure a run, it evolves through it. The prefrontal cortex and the art of mental endurance. Long runs are not only physically taxing but mentally challenging as well. The prefrontal cortex is heavily engaged during endurance running. This part of the brain governs executive functions such as planning, judgment, and emotional regulation. Over time, regular long runs enhance the prefrontal cortex's ability to manage discomfort, delay gratification, and stay focused on long-term goals. This leads to increased mental toughness, a quality that extends beyond running into everyday life. Runners often report improved self-discipline and a greater sense of purpose, which neuroscientists believe may be rooted in these prefrontal adaptations. The amygdala and emotional regulation. The amygdala, the brain's fear and emotion center, also undergoes modulation during a long run. Initially, running may stimulate the amygdala as part of the fight or flight response. But as the run progresses and endocannabinoids and serotonin levels rise, the amygdala becomes less reactive. This means that long runs can help tone down emotional reactivity and promote emotional balance. In fact, regular aerobic exercise has been shown to decrease symptoms of anxiety and depression by regulating activity in the amygdala and enhancing the brain's emotional resilience. Serotonin, dopamine, and the mood connection. The biochemical cocktail stirred by a long run includes not only endorphins and endocannabinoids, but also neurotransmitters like serotonin and dopamine. Serotonin is responsible for mood regulation and feelings of well-being, while dopamine plays a role in reward, motivation, and pleasure. Prolonged exercise increases the availability of these neurotransmitters, which is why many runners report feeling a sense of satisfaction and clarity after a run. The effects are not fleeting. Regular running can result in long-term upregulation of these systems, providing a natural antidepressant effect. Meditation in motion. The default mode network. As the run stretches on and rhythm takes over, the brain enters what some psychologists call a flow state. This is linked to the deactivation of the default mode network, DMN, a set of brain regions active during self-referential thinking, daydreaming, and mental chatter. Long-distance running provides a rare break from this activity, much like meditation. As the DMN quiets down, the brain becomes more attuned to the present moment. This may explain why runners often describe feeling zen or spiritually connected during a long run. It is not just physical, it's profoundly psychological. Long runs as a natural antidepressant. The ability of long runs to act as a mood stabilizer is now well documented in mental health research. In clinical trials, aerobic exercise has been found to be as effective as medication in treating mild to moderate depression. This is partly because running increases the production of tryptophan hydroxylase, the enzyme that synthesizes serotonin. Long runs also reduce systemic inflammation, which has been linked to depression. Over time, consistent running rewires the brain to become more emotionally stable and less reactive to stressors. Memory, creativity, and cognitive enhancement. Beyond mood and emotion, long-distance running improves various cognitive functions. Studies show that runners tend to have better memory retention, faster reaction times, and improved problem-solving abilities. This cognitive boost is partly due to increased BDNF and better blood flow to the brain. Furthermore, running has been shown to enhance creative thinking. Many writers, artists, and inventors cite running as a key part of their creative process. The rhythmic motion and release of neurotransmitters seem to unlock parts of the brain responsible for divergent thinking and imaginative insight. If you like this video and would like to see more like it, please give it the thumbs up. Leave a comment and click the button to subscribe.